something about the soil. It was about, it was geotechnical. With the engineering, I felt like I could actually touch the soil. And then after I got into a lab and then I got to go out on drill rigs, it was so much based on experience and what you have seen and how that soil behaves. It's not going to be the same every single time. And so there's always a challenge with it.
It's a great industry for people who like new things that pop up underground and who can deal with changes as they happen. So it's rewarding and always full of new things.
We definitely get the opportunity to be designer and builder all in one, and not everybody has that offering. Not every engineer has that ability in the pathways that they choose.
It's very satisfying. Most of the work we do is never seen, but it's still satisfying to drive over a bridge knowing that I've had a hand in constructing it, or looking at a high-rise building, any beautiful building, knowing that deep below the ground is my contribution to that structure. It's just a very satisfying feeling.
It's a very big industry, so you have a great opportunity to advance and to be able to move forward in your career and become valuable to the industry or the company you're working for.
What I like about soil is that it's sort of a mystery below the ground, right? You only get to see a little bit of it at a time and then try to interpret what's going on. So it's sort of a puzzle that you're putting together.
DFI continues to expand globally as regional chapters grow and reach more practitioners with content that meets local needs and goals. Regional chapter leadership is steady, and local staff are dedicated and enthusiastic, liaising productively with DFI headquarters. We are communicating effectively by assembling more frequently through in-person meetings and conference calls to maintain momentum on more than 100 ongoing projects and programs. Stay tuned for what the future brings for DFI. Get involved. Join the DFI community. Become an active member of a DFI committee and join us in making a difference.
Hello, friends. Good evening, good afternoon, good morning. Take whichever wish you want. But it's an exciting evening for me in India, for sure. On behalf of Deep Foundations Institute of India, we bring this webinar series. And DFI India welcomes you all for this fourth webinar. I'm Amit Prashant. I'm professor of geotechnical engineering at Indian Institute of Technology, Gandhinagar. And I have been associated with DFI India, exciting venture that does believe in quality. And you will see through this series of webinars that how much learning we can have from the high quality stuff that is being poured on us. So I again welcome on my behalf as well to all of you to this webinar. Please note that recording of this webinar is prohibited. Certificates will be prepared and emailed in approximately 2 weeks, so you don't need to worry. An online webinar recording along with the presentation slides will also be available in approximately the same time. In case of any help you need during the webinar, you see the numbers and the email. I think they will be on the call. If you need to contact them, please feel free to do so. You can also type in the chat box on the side of the GoToWebinar that you have open. There are some screens, I think, that you look at them, how you can manage your screen for the better viewing and connection as well. So next one, please. Yeah, there are some handouts that have been put in. I think they are all related to this webinar series and this particular webinar as well. Besides that, there is a conference, DFI 2020. There is a brochure there. So you can look at that details for sponsorship, for attending the conference, registering for it. And there is some information about sheet filing and related to this webinar, some learnings that you will have in this as well. And the chat box, I think, as I mentioned, you can ask questions in that, but put your name and organization's name so that we can address, introduce you who has asked question before it is answered. The question answer session is after the presentation. So you, I think, can wait for that time. So this webinar is sponsored by ArcelorMittal Projects India Limited, Private Limited. And also there is one more sponsor on the co-sponsor, that is Teamwork Engineering Solutions Private Limited. And we thank both of them for their wonderful support to this DFI India venture. There are sponsorship opportunities for for this webinar series and for the upcoming webinars 5, 6, 7 that are listed below. Some titles are given. The next one in this series will be on 23rd September on deep cofferdams, bay walls, and breakwaters built with circular cells by Mr. Joao Martinez from ArcelorMittal. And next one on 7th October, title yet to be finalized. But Tomaka Hirose from GChem Singapore, and webinar 7, 28 October, that will coming soon. So please write to MMA@DFI India for any sponsorship opportunities that you would like to explore. So far, the registration in this registration distribution is quite balanced with a lot of people from industry, I would say, from consultants to contractors, you see in yellow and green, and academia 32%, 1/3, and there are some few manufacturer suppliers and specialized contractors as well, and quite a few owners. That's wonderful to see. Yeah. So welcome to all of you. We have several countries participating with us, and the new countries that are marked with green, they have joined this time: new, Bhutan, Bolivia, Egypt, Finland, Germany, and Netherlands. So it has become more like a global platform, and we welcome all the audience that we have from different countries. Thank you for joining. The sequence of this webinar will be, we'll have a speaker introduction that I will talk about, and then we'll have presentations, then a few small promotional videos, and then the most important question and answer session. And we will have some details of the upcoming virtual conference. It's an innovative thing that we are doing with some, you can say, great experience in learning. Then at the, of course, end of the webinar. So today webinar is state-of-the-art sheet pile installation techniques. The speaker is Mr. Ernst Weber, sheet piling specialist from ArcelorMittal. He has just joined us. Wonderful to see you, Ernst. And yeah, he's graduated from University of, I hope I can pronounce it right. And excuse me if I can't, Karlsruhe, Germany, with a Master's of Civil Engineering, specialized in geotechniques. After having worked for different construction companies on international projects, he joined ArcelorMittal sheet piling in 2002, long time ago, and was since then involved in the planning and execution of sheet pile projects all over the world. He is specialized in installation equipment and construction methods as well. I think nobody better than him to talk on this topic, I can imagine. Yeah.
Thanks a lot.
So with this, we welcome Ernst to speak. I think the next slide. Take over, please.
Okay, so let me just get the laser pointer. Hello, everybody. Our session today will be on the topic of state-of-the-art sheet pile installation techniques. There's quite a lot to talk about, so we will touch sometimes only the surface, sometimes we will go a bit deeper, and I invite you to ask a lot of questions, or after the webinar, if there is more to be clarified, just contact us, we will help you. The picture that we see here is a nice sheet pile job that we did 2 years ago at Frankfurt International Airport. It was the construction of a new terminal, and because of very high water tables and changing geometries of the underground structures, around 3,000 tons of sheet piles had to be installed. Some of them stays in the ground, some of them had to be extracted about a year or 2 years later to be reused on different job sites. That's a very important thing that we will learn today, that sheet piles are very versatile and we can use them over and over again. Just to give you a quick figure, every hour on every day, all over the world, around 1,000 linear meters of sheet piles are installed. Be it new, be it used sheet piles, 1,000 meters per hour, every day in average all over the world. So that shows how big the use of sheet pile is everywhere. It's a very important construction product. That brings me to a very interesting question. Who of you has ever worked or designed with a sheet pile? Just very interesting to know what audience we have today. So I guess we will have very quickly an answer. Oh, okay. Nearly 60% have already experience with sheet pile and 40% do not have. Well, let's see that after this webinar, the number of sheet pile users will definitely grow. Thanks a lot for this quick poll. Now let's go back in time. Sheet piles have been invented more or less 100 years ago. Steel sheet piles, very important. And here we see two very nice pictures. On this one, we have a 1922 handheld driving hammer. So all we need is 10 people, a rope, a little guiding for the hammer, and it's nothing but a drop weight that is driving a pile into a river. The other picture is dated from 1924. Here we see already a steam-driven hammer, and here inside a river in Germany, the sheet piles are already driven in the ground. So for more than 100 years, sheet piles exist, and they are every time used when, for example, water is there, when no soil or no soil to work is present, and we have to construct structures from scratch. Today, we are much more advanced. So when it comes to the construction with sheet piles, the first thing we do is we calculate. We need to know what kind of section modulus, what length we need. And then the second important thing is the piles we have calculated must be installed in the ground. And this can be just as challenging or even more challenging than the calculation of the project. So we need as much information as we can get on the soil, like friction angle, like cohesion, like SPT or cone penetration testing, borehole data. As much as we can get, we would like to have to evaluate the right methodology and the right equipment. Basically, we have two types of soil. One is granular soil, like sand and gravel. That's perfect for vibrating, because the soil, when the vibration of the pile starts, is more or less liquefied temporarily, and the pile slides into the ground. After vibration is finished, the ground is settled again, and we have a pile that's fixed and that will not move anymore. The other big soil type is cohesive soil, like clay, silt, silty sand. That can be very challenging to install piles. Here, the use of an impact hammer is normally very good, or very strong normal frequency vibro hammers can also do the job. We can also install sheet piles in rock, but that's a different topic we will not touch today. We can do another seminar on that. When we go to the installation of a sheet pile, it's very important that the installation method, the installation equipment, and the soil is taken into account. Always these three together. We see here a very small hammer on a very large pile. You can imagine that does not work. We have here a huge hammer on a very small pile. Yes, the pile will go into the ground, but you have no control. So both options are not the ideal one, and we have to check what is the best installation equipment for the given pile to get best installation results. If we take a look at the system of vibro driver, pile, and soil, then it's clear that we have on the top of the pile most of the energy, but for sure least of the resistance. The deeper we go into the ground, the energy diminishes, but resistance is growing and growing. So we have to find the right equilibrium between piling energy and soil resistance to get the job done. Resistances along a sheet pile. This is a very rough figure, but it shows you what we have to deal with. If we have 100% of resistance, then that's point resistance, so at the end of the pile. It's skin friction, or the surface of the pile, and very important thing, what is a sheet pile about? It's about interlocking. So we surely have some friction in the connecting point, which is the interlock of a sheet pile. Those are the three major resistances along a sheet pile. The point resistance is generally between 10 and 20%. The skin friction can be assumed 30 to 50%. And if you sum it up, you see that there is a lot of resistance left for the interlocks. This brings me to the next question. Do you believe we can influence the resistances along a sheet pile? Just type yes or no. And as we have already 60% of the participants with some sheet pile experience. Let's see what the other 40% say. The interlock friction, the point resistance, and the skin friction of the pile. Can we influence that? Do we have any chance? Let's see what the result is. Oh, I'm very happy. Nearly 90% say yes. 10% around no. Well, yes, we can influence. That's why it's so important to know the resistances, because we can work with them. Point resistance. How can we influence the point resistance? It's, for example, by choosing a single or a double pile. We increase the point or we make it smaller. We can do pre-drilling to break up the ground before the pile tip. This all is reducing the point resistance. Yes, we can influence. Skin friction. Can we influence the skin friction of a pile? Oh, yes, we can, quite a lot. We can go for a single or a double pile. We can do water jetting, for example, which is lubricating the ground, and the pile is sliding in with much less friction than if we would just drive it dry. Then comes a very important point. How can we reduce the interlock friction? We can use grease, for example. Before piling, we just put with a little brush standard ordinary grease into the interlock, and this will help to reduce friction quite a lot. We can use bituminous filling materials, or even simple soap can reduce the interlock friction a lot. So it's very important to know where are the resistances and how to deal with them. When we go to actual sheet pile installation, then around 70% today is done with a vibro hammer. It's the quickest way of installing. It's very versatile. You can use it everywhere. And the speed of execution is the big advantage. We had job sites where up to 100 linear meters of piles of wall was constructed just in one day. So quite a lot. So if we go now into the details, important is that the dimensioning of equipment has to be done in the correct way. So in this case, for example, we have a sheet pile with a section modulus of 3,600 cubic centimeters per meter, 23 meter pile length. The weight of the double pile is 5.6 tons. The soil is sand, clay, partially dense. And then we have this nomogram where we have here the driving depth, we have the pile weight, and we have curves. This is taken from piling manufacturer's handbook. So we have normal or easy driving work, and just by making the correlation between driving depth, pile weight, and the curve for the soil conditions, we get in this case, for example, a centrifugal force of 2000 kilonewton. So we know quite well what kind of vibro hammer we have to take. So at least 2000 kilonewton machine should do the job. For example, in the recommendations of Waterfront Structures, the EAU 2012 is the latest version. There are also recommendations on how to dimension the piling equipment. If we take a look at the connection between vibro hammer and pile, then the clamping system is very important. We used to work in the old days only with a single clamp. That's what we see here on the bottom. But the wider the piles get, the more important is to use double clamping systems, especially here for the large Z piles, because the double clamping system is bringing or is introducing the force in the axis of the sheet pile, while with a single clamping system we have a certain eccentricity which will increase the resistances during driving. And as we just saw before, that's what we want to avoid. With U-piles, it's just the same. We can work with a single clamp in the middle of the W pile, or we can take a double clamping system to introduce the forces in the best way into the pile. Nowadays, we see very often small excavator mounted vibros that can be used for small projects. We see here an example. So it's a standard excavator that doesn't have a shovel, but a vibro driver on the top. This system is very quick and very smart because you don't have to transport much weight and you can use standard machinery, but you are limited, as we see here, with the length of the pile, because the pile has to fit under this excavator. And for sure, what always has to be checked is the machine stability, that we do not overload and the machine does not tip over. Safety is always the most important thing when it comes to a piling job site. When we look at the dimensioning, then we find different manufacturer recommendations and also vibros like this one here with a so-called side grip. So here the problem of the pile height is no longer existing, but again we have to check pile length and pile weight together with the right sized excavator to be sure that we have a stable installation equipment. So if the longer the pile gets, well, the less it can weight, because the stability of the machine is the limiting factor. That's why you see here 6 meter long pile can weigh up to 2,800 kilo, while a 16 meter long pile only can have 1,300. That is the limiting factor of the base carrier machine. If we look at bigger job sites, then it can be very beneficial to use these telescopic leader rigs. We have here normally a high frequency hammer and a hydraulic mast that can develop a certain pushdown force. This allows us to work with a rather small vibro because the machine itself can give an additional energy to get the piles in the ground. We had job sites where we installed 30 to 40 double piles per day. Also, this machine has a crane equipped in the mast, so you don't need any auxiliary equipment. Just one machine and 3 to 4 guys that help, and then you can do 30 to 40 double piles per day easily. And the high frequency vibro that's normally attached allows to adapt quite easy to changing soil conditions. So these are really state-of-the-art installation machineries. When we go to large job sites, let's say like offshore jobs, then we can use a fixed lead, like we see it here. Those machines can weigh up to 200 or even more tons. So here we really look at heavy piling equipment. We can install piles up to 40-50 meter length with these leader guided rigs. And the big advantage is we can do inclined pile driving. When we have to install anchor piles, for example, we can, with this spotter, for example, we can push or pull the leader into a certain angle and install inclined piles. That can be very important for the installation of huge anchor piles in offshore quay walls, for example. The if we install the piles, it's very important that the guiding of the piles is absolutely accurate. As we have seen some slides before, the interlock friction is a major part of the resistance along a sheet pile. So we have to make sure that the piles, the wall, is as straight as possible. If the piles are bent or they are leaning in one or the other direction, we immediately increase tremendously skin friction and interlock friction, leading to problems in the installation. So here, for example, we see a fixed leader guide machine, and we have on the bottom a one-level guide frame. This is making sure that the sheet piles are in good alignment and that they are in the design place. We can also work with a crane and the vibro free hanging on the crane, and then best installation results are surely achieved when we use a two-level guide frame. So never underestimate the good guidance of the sheet pile. That's half of the job done. Yeah, also very important, the crane dimensioning. When we work with a crane, we have the big advantage that we can work in a certain distance from the crane with the sheet piles. That can be, for example, when you work on a quay wall and you have to reach out for 10 meters into the sea, then this way, this methodology can be very good. So what do we have to consider? We need to know the pile weight, the vibro weight, respectively hammer if we use an impact hammer. We need to know the weight of the guide frame, because that also has to be lifted by this crane here. And we have maybe to consider combined lifts. We have a pile that's installed in the ground, but it's maybe on the wrong position, so we have to pull it out again. So it's the vibro plus pile weight plus soil tension. That has to be considered for the crane dimensioning. Very important, but that's the good thing about sheet piles. We install them, and if we find out, oh, there's something wrong, we just pull them out again. That's the only material that allows you to do so. And then for the crane dimensioning, it's for sure very important to know the working radius. How far away from the machine do we have to work with the pile and the vibro? Because that is a big influencer on the size of the machine. Just to give you a quick idea, this is a job site that's actually going on in India, where we install up to 45-meter long sheet piles. Very important what we see here, we have a clean and very spacious surface. When you look at concrete job sites, you have sometimes concrete spill all over. It's dirty, it's wet. That's what we don't have on a sheet pile job site. It's a very safe work condition that we are facing here. So for the worker on the job site, it's very nice to work with sheet piles because they come home not as dirty as from other sheet pile job sites. The other big installation method is the use of an impact hammer. Impact hammers exist since Roman times, already 2000 years ago. The Romans had handheld masses that they dropped on wooden piles to construct bridges and roads for their mainly military purposes. Today we have either diesel hammers, they can be free hanging or in this case leader guided, or we have modern hydraulic hammers that are used for pile installation. Here, for example, this is a 40-ton hammer sitting on a 1.80 meter pipe pile. So the size can be quite big of these machines. When we this should move further now. Can you please go one slide further? Seems like mine is not. Okay, very good, thanks. When we use an impact hammer, it's very important to use the fitting driving cap with it. We see here that's the counterpart of the clamp at the vibro driving. We have a helmet that is covering more or less the full shape of the sheet pile, but leaving out the interlocks. So we can work with this driving cap in between a wall. And if one sheet pile does not go down with vibro hammer, we can always switch to impact hammer driving, which will normally lead to full penetration of the sheet pile. Details can be found at machinery manufacturers or also at the sheet pile manufacturers. We also have some ideas on the driving caps. So there should be. Can you go one slide further, please? Looks like I've lost control a bit. Okay. Very important when you do piling is not only what material to use and what pile to use, but it's also when to stop. So we have to take a close look at the refusal criteria, which is clearly defined. So can you go one slide further, please? Somehow my cursor doesn't allow me to do so. We have certain recommendations, which is 5 minutes for continuous vibrating of a sheet pile. If the pile is not moving down after these 5 minutes, then you should stop piling. If you go on, there is a risk of damaging the pile or the machine. What can you do? Well, get a bigger vibro or move to impact hammer driving. When we move to impact hammer driving, then there is also a refusal criteria. That's 2 centimeters per 10 hammer blows. If you have reached that, then it's a technical limit, and you have to check where you are. If you are only 5 centimeters away from your pile driving objective, then you have reached the technical limit. That's okay. If the pile is still sticking out for 2 meters, you have to get a bigger hammer, or you have to think of water jetting or pre-drilling just as an installation aid to get the pile down. But very important, if you go on with hammering and the pile is not moving, you will destroy the pile head, or worst case, the machine will face a problem. And very important, when you do a mix of these installation methodologies, always use vibro first and hammer last. Never the other way around, because a hammered pile is really sticking in the ground and you will not be able to move it again with the vibro. Installation with low vibration is a very important topic today. In the old days, everybody assumed, together with sheet pile installation, very heavy shaking of adjacent buildings, but that is technology 30 years ago. Today, we have hydraulic pressing systems. When we take a quick look into the historic development, then we see that the first press was already constructed in 1958. It was Taylor Woodrow's Pilemaster that came into the market at that time. So already quite an old and proven technology. At the time, they had a pressing force per cylinder of 229 tons. Just to compare, today we are working between 80 and 120 tons. It had a stroke of 70 centimeters, which is quite a lot. It could work with single Z and U piles, pile width 500, 600 millimeters, which was the standard in 1958. And we had a machine weight up to close to 12 tons. It was working free hanging on a crane. How is the pressing system working? That's what we see here. Basically, when we start, we have the weight of the machine and the weight of the panel of sheet piles that is to be installed. To overcome the resistance in the ground, we have to mobilize all these weights together, and we start pushing with 2 cylinders. Normally it's in the middle that we start. We push the piles into the ground for 50, 60 centimeters, and we have the counterweight of the sheet pile panel and the machine that is giving the reaction force. Then we go on with the next 2 piles. The system should always be symmetric to make sure that we don't have any leaning in whatever direction. And the deeper we go, the more friction we develop along the pile. So this additional friction is also adding up resistances so that we can, the deeper we go, the pile is held by the ground more than by the machine and the weight of the other piles. This was basically the invention of 1958. And that's how it still works today. When we go further into history, can you please click? Yeah, here we go. In the 1970s in Japan, they invented special presses that used the already driven piles to walk on them. Japan, very highly populated, very dense housing and not much space. So they needed a system that was able to work with the least space possible. And that's where these self-walking presses came up. They press one pile after the other, and the reaction force is given by the piles that are already driven in the ground. So it's like an ant crawling over the sheet pile line that it has created. In the mid-70s, there were some guys in Germany doing some inventions and testing with a combined drill pressing system. So we have a 4-cylinder press machine that also had an auger or 2 small augers fitted on the machine, so you could press and drill at the same time. It was possible to use single Z piles, and it had a stroke of 50 to 75 centimeters, which is about the same that we are facing today. If we look at today's pressing systems, then we normally find these leader-guided machines. We see here the same hydraulic leader that we had some slides before with the Vibro. We have a 4-cylinder press. So in the beginning, the machine weight is the counterweight for the installation. And the deeper we go into the ground, the more the ground friction is building up. And as I know that it's quite hard to imagine, here we see the different setups for a pressing system for Z piles and for U piles. The U piles demand a little bit more of machine engineering, while the Z pile press is rather a straight line. And as it's really hard to imagine in theory, we have a small film that illustrates how pressing is done. So if you please show the film now.
A foundation pit had to be excavated for the construction of a sports shop subsidiary in the city center of Constance, Germany. The foundation pit retaining wall was installed using AZ46 ArcelorMittal sheet pile profiles with lengths of 10 and 11 meters. The profiles will remain in the ground. The stipulated installation method was vibration-free pressing, since the adjacent buildings were in extreme danger of collapsing. The contractor decided to use his Liebherr piling and drilling rig, type LRB 155, equipped with a Liebherr BVV sheet pile presser, type 4080. A special feature of this model is its ability to work with both U and Z profiles. The sheet pile profiles were supplied as double sheet piles and were connected to panels of 4 sheet piles on site, which were subsequently pressed into the ground. The carrier machine's dead weight and the downcrowd force supplied by its universal slide usually allows for an immediate installation advance before the actual pressing process has even started. Several meters can be achieved depending on the prevailing soil conditions. Interlock friction should be reduced during the pressing process. For pressing the sheet piles into the ground, they have to be guided in the lower section in order to guarantee their correct alignment. The guiding tongs should consist of strong double T beams and be arranged on the ground. The free flange end of the sheet pile panel is guided by a guide block during pressing. This prevents the sheet pile from turning within the guiding tongs. Greasing of the interlock also helps to reduce interlock friction. Another special feature of the Liebherr BVV sheet pile presser is the system of torque monitoring. This system automatically stops the pressing process if the bending torques resulting from the pressing process exceed those which can be absorbed by the carrier machine. This provides utmost safety for the carrier machine and the leader. The actual pressing process can be controlled automatically as well as manually. 1 or 2 pressing cylinders work alternately until the sheet piles are installed to the required depth. In this alternating pressing method, the skin friction forces of the stationary piles are used in addition to the weight of the carrier machine. All working processes are monitored by the Litronic control system of the LRB, displayed on the monitor in the operator's cab, and transferred to the Liebherr process data recording system. The data can be printed or stored on a memory card on a PC. The pressing method using the Liebherr BVV presser is equivalent to traditional vibrating or impact driving methods in terms of application potential and handling.
Wo sitzt? Okay, here we are back again. That was a nice film to illustrate how pressing is really done. You might have seen that in the animation there was a guide frame illustrated on the bottom, which in reality was not existing. That's for a reason. The sheet pile that were used is one of the strongest you can get. So the potential of getting out of balance is rather small in this case. That's the reason why there was no guide frame. If we go to the self-walking presses, then we can use the same type of helping methods as with all other methodologies. We can do standard pressing, we can do water jetting, or if we have to go through very hard ground layers, or if obstacles are maybe present, we can go to the super crush mode, which is an auger that's already mounted on the machine, so some kind of pre-drilling. Can you please go to the next slide? Doesn't work. Please go to next slide. When we work with these kind of presses, we have the same tables and nomograms that allow the user to choose for the given soil condition and for the given sheet pile, for example, Z pile or U pile, in certain conditions, the right machine and the right methodology. Here, for example, standard pressing. If SPT goes higher than 20, then we can use water jetting, for example, and above 50, super crush mode, also pre-drilling would be the perfect way to go. So depending on the soil condition and the machine that we have, we can choose the right installation methodology. Okay, and apart from the standard pressings, we have also interesting new developments like the resonant pile driver. That's a machine that's still in development stage. That's this one here that uses the resonance of the pile to install the pile in certain ground conditions. And years ago, there were some sonic vibrators on the market, but there is still some scientific work to be done. Here we see some very nice pictures of projects that have been done in modern sensitive areas. Here we see the sheet pile line installed in the middle of a chemical factory. That was absolutely tremendous. There were no vibrations at all allowed. So we had to find a way to install more or less vibration-free all the sheet piles, which was done successfully. Then we see here the surrounding wall of a fuel storage tank. The sheet piles are the last barrier in case something is happening, some hazards, some accident and oil spill should be present. Then the sheet pile will act as barrier to prevent the oil from entering the clean outside area. What else can we do to reduce vibration? I told you before, around 70% of all sheet piles are installed with vibro hammers. So the choice of the vibro hammer is very important. When we have a heavy duty standard frequency one, we should stay away at least 25 meters from structures. If we have to go very close to buildings, we can use high frequency machines, or the latest ones, high frequency with variable moment, that allows you to work within 1 meter of the foundation of the next building. So very important, the choice of the right vibration equipment. We can use water jetting to reduce tow resistance. Remember, we had it before with the resistances along a sheet pile. It lubricates the pile, so we reduce also skin friction, and we can combine it, for example, with tow strengthening plates or other methods. Very important, the water flow has to be very little and very controlled. So we see here 2 jet pipes per sheet pile, so 4 on the double pile. If we use huge pipes, we create erosion in the ground, which we don't want. We just want to lubricate a little bit. And also here we have a little film to illustrate. If you could show that, please.
Today, vibrating sheet pile walls is a common method, especially in inner city areas, for stabilizing excavations against soil pressure. The technical parameters of vibrator and sheet pile walls make this method of construction more transparent than other methods. With careful working methods, basic machines and vibrators of modern design are synonymous with low noise and vibration levels, faster job completion, and consequently in harmony with ecology and economy. The vibrator, in this case equipped with a sheet pile feeder, is positioned on the sheet pile and so sets the sheet pile and the adjoining soil in vibration, shifting the latter. Peak pressure and skin friction diminish and the sheet pile penetrates the soil. Jetting-assisted vibrating belongs to the category of installation aids and is used as a supporting measure for the installation of sheet piles, beams, and pipes. It is a successful method to reduce the peak pressure of the vibrated element, as well as skin and lock friction, and to break up the adjoining soil. Moreover, vibration time is shortened and the vibrated element is protected from deformation. Machine overload is prevented and soil vibrations are minimized. The number of jet pipes mounted on the sheet pile depends on the soil condition. The BVV jetting system consists of a water tank, rotary pumps driven by powerful electric motors, and an elaborate electronic control. The jetting system is remote controlled. The jetting at the bottom of the sheet pile results in the loosening of cohesive soil layers, a shift in granular soil layers, and the creation of a water film along the sheet pile, functioning as a lubricating film and ensuring better progress of the vibration works. If certain criteria, for instance the choice of the vibrator, the number of jets, the amount of jetting water and the jetting pressure are adhered to, the sheet piles can be installed even in very compact and changing soils. Supported by jetting-assisted vibrating as an installation aid, it is possible to economically penetrate soils which were considered to be impenetrable through vibration until up to only a few years ago.
So that was the water jetting. In case we have hard ground conditions, maybe some rock layers in the ground, or if obstacles, boulders, or old trees are known to be encountered, we can always use the pre-drilling method to work around these obstacles. So we open a hole in the ground, normally at the area of the sheet pile interlock, and we destroy the obstacle or we push it away, and sheet piles can be installed. Here we see an example from Vienna where we did piling in the middle of the town. So to minimize vibration on neighborhood buildings, machine 1 was doing the pre-drilling while machine 2 was doing the installation of double piles. Here we see also a double clamping system. So let's go to the next one. Very important question that comes up from time to time is submerged piling. What can we do when we have to install piles underwater? Well, basically two major ideas. Option 1, you check what vibro you have and you check with the manufacturer, is this vibro capable of working underwater? And quite a lot of them are capable. So that has to be checked with the manufacturer. You just lower the vibro with the pile below the waterline and you can install your sheet piles. If the vibro is not capable for underwater work, then we can use a follower, an extension piece like we have it here. It's a steel beam that's fixed on the vibro, and at the end of the steel beam we have the clamping system. So it's just an extension. The vibro is always above the waterline while the pile is going to be installed underwater. Very important, extension beams surely have a certain weight, which demand a bigger vibro machine, because you have to vibrate the extension also and not only the pile. A very important topic when it comes to sheet pile driving is the quality control. When you receive the piles from the mill, you already get a certificate. So you have controlled normed material specifications, which are easy to control, which are certified. And then when it comes to the job site, vibration monitoring is surely a very important topic. So the DIN, it's the it's a code that deals with vibration impact on structures, DIN 4150, part 3. is given recommendations, for example, how far away you should stay with your piling works from the foundation of a building, depending on soil condition. If it's cohesive or non-cohesive soil, you can assume at a certain distance that no harmful vibration will happen. But today we are much more advanced. We can equip either the grounds or the whole house with measurement devices, and when we vibrate quite close to this building, let's say within half a meter from the building, we can measure the wave velocity that is coming to the house, and in case it exceeds values that have been predefined, we can always stop piling works. This is very easy to do. Here we see, for example, this is one of the measurement devices. It records the wave velocity at this point, and you see here we can vibrate quite close to existing walls, and this will give a signal in case something is out of the ordinary, or if the levels that are measured exceed the predefined ones, then the driver gets a signal and he has to stop, and they can think of what to do, either change the vibration methodology or change the vibration setup. So quite easy to deal with. The same applies for the wall integrity. Once we have the piles in the ground, let's say 10-12 meters deep, it is for us impossible to see how does the pile look like. So we have this kind of checking tool that can be mounted on the sheet pile. We have this little bolt, that's what we see here, that is attached to the driven sheet pile. And when the next pile comes down and it reaches the position of the bolt, it shears the bolt off. And with a little control box 10 meters up in the air, the foreman on site can easily check, yes, bolt is sheared off, interlock is connected, pile and wall are okay. So this is a very easy method of controlling on the job site that the accuracy of the piling is correct. Can you move one further, please? Then we do a lot of projects in maritime areas. We do a lot of excavation projects. We do sheet piles for dikes and flood protection. But sometimes we do different things. What I show you now is a project that's actually going on now at this day in Munich. Here we go. It's a temporary house which will be used as a theater. Point, let's go back. That was too quick. This is a temporary cultural happening area. It is, can you please go back to the slides? It is constructed in the middle of Munich at a space that's temporarily unused. Construction time of what we see here, of the surrounding walls and the structural elements, is up to now about 2 weeks. So they started 2 weeks ago. We see here there's a little drill, because we are in inner city area and we want to reduce vibration impact. Pre-drilling was used, and also because we know in Munich we have quite hard soil conditions. Sometimes it's necessary to help the sheet pile to go into the ground. So here we see drilling method. Then we have here the piling rig with hydraulic leader and a high frequency vibro attached. That was the installation rig. We see here the crane, and the result of the piling work will be the future theater. Here we see the architect's drawing. This is how it will look like once it's finished. This theater will be used for the next 3 years, and then they will dismantle the whole structure. Everything will be dismantled but not scrapped. Everything will be reused. So the sheet piles that are driven now will stay there. And when the time of use is over, the sheet piles will be removed, cleaned, and taken to the next job site. That's the biggest advantage that you can have. It's the sheet pile can be used as long as you like. So it's a very economic and very ecological product because we can use it over and over again. And if we really have reached the end of the lifetime, we can take it back to the mill. We can melt it down and create new sheet piles out of it. So very impressive job site that's going on right now. So let's see, where can you find written recommendation on sheet pile installation? Just to mention a few, let's go back. It's the Eurocode 12063, which is dealing with the with execution of sheet pile walls. The Eurocode tells you, it's the technical code for sheet pile works with a big annex that gives examples how to handle, how to install. It's a very good reference code. Then we have recommendations for waterfront structures. It's the EAU. Chapter 8 is dealing completely with sheet piles. It's around 150 pages that tell you everything you need to know about sheet pile structures and maritime business. Then we surely have piling handbooks from the different sheet pile manufacturers. So you can contact the manufacturer of the sheet pile and ask for help every time. And we surely have the machine manufacturers that also offer catalogs and brochures, like you saw in the presentation for the dimensioning of equipment. They are all eager to help in case of doubt. So there's a big source of information in case you want to use sheet piles and you're not sure. You can always come to the manufacturer and ask. We will be glad to help you out. I thank you very much for the attendance and wish you a good day.
Thank you, Mr. Weber. This was a proper in-depth presentation on installation techniques of sheet piles. We thank you for this wonderful presentation. So moving now, we also would like to thank ArcelorMittal Projects India Private Limited. They are our series sponsor for this webinar series. And we would also like to thank Teamwork Engineering Solution Private Limited from Chennai. They are our webinar series co-sponsors. Before moving to question and answer session, we'll see the small promotional videos from them, and then we'll continue with the question and answer sessions.
My origin is somewhere in the depths of the earth, and my story began billions of years ago, when I was born in a blaze of fire. I helped you survive through the ages. I've changed the way you work, and I've changed the way you live. I've been part of mankind's greatest achievements. I allowed you to expand your frontiers, to explore the land, the water, the skies, and even the universe. Throughout the centuries, I was reborn again and again. I'm known for stability and strength. My quantity is measured in millions of tons, but my quality is defined in millions of an inch. I've stretched the possibilities of human imagination. I've inspired you to shape your visions and reach new heights. Once I'm back to where I came from, I can become virtually anything you can imagine. I am more versatile, than I have ever been before. I'm always with you. I'll protect you and guide you. I'm all around the globe, wherever you go. I'm everywhere and will always be. I am the engine of innovation. I am the pulse of the modern world. And you'll build your future on me, because I am steel, the fabric of life.
Now, the most awaited part, I would like to invite Ms. Amrita Vijayan from ArcelorMittal to coordinate the question and answer session.
Thank you very much, Ernst, for the presentation. And we have a lot of questions from our participants today. I'll take a few based on the time that we have. The first question is from Soumya from L&T. What she asks is regarding pre-boring. The question is, during pre-boring, when you install sheet piles after pre-boring, won't it alter the soil properties that the sheet pile was originally designed for?
Interesting question, and a topic that we face quite often. If the boring is done in the recommended way, that it's only limited with a certain dimension, let's say 1/3 of the sheet pile width, and if it's not in the, it's not overlapping, then we can assume that there is nearly no soil changing. We did just recently calculations with finite element programs, and we found the difference, so the theoretical difference in soil conditions is less than 5%. So pre-drilling has no negative influence on the soil conditions.
Okay, thank you. The next question is also actually from her. The question is, you had shown jetting assisted driving, water jetting. So in jetting assisted driving, how effective is it in commercial or clay soils?
Not really effective. Jetting works best in sand, gravel, dense sand, because there the water can develop its full lubricating force and strength. In clay, there is something like a high pressure jetting method, but honestly, out of my experience, it doesn't really work. In clay, water jetting is rather ineffective. In clay or cohesive soils, drilling is the best option, or the use of a big impact hammer.
Okay. The next question is from Mr. Vivek Pipalia. I don't know the organization, but it's a question regarding installing sheet piles near an existing railway track for construction to adjacent structure, probably retaining the existing track. Any suggestions on installation? So what I understand is, if there is no pressing method or a vibration-free pressing is not available, what kind of equipment can we recommend for a very critical structure like a railway track and adjacent work that's going
on? Very nice question. Especially in Europe, we have railway-based equipment, which is either vibro or impact hammer, sometimes pressing. It is possible to work very close to existing tracks. We have quite a lot of records on that. For sure, high frequency variable moment machine is recommended to minimize the influence. When you use an impact hammer, the possible settlements are also rather limited, but installation speed is less good. So you need more closing times. What would always be recommended is surely a monitoring system, that you have a surveyor that can detect in case there should be some partial settlements, that you can immediately put some new gravel under the tracks. But basically, yes, we do quite a lot of piling along railway tracks, and it's possible with standard equipment. It just has to be the right one. So high frequency variable moment machines, not too big, and as pile length also is rather limited, the danger of settlements is not so big. So it's done very often, but yeah, should be done with the right equipment.
Yeah. Okay. So the next question I think I'll take from Mr. Avik Mandal from Lee Associates. So what he asks is, can the vibro hammer be used for driving sheet piles through very dense sand or silty sand, typically having SPT greater than 100? So
wow. Okay, 100 is already quite big. I always say, when we get SPT values, even if it's 100, that means the probe entered the ground. If the probe enters the ground, the sheet pile will anyway enter. So yes, it can be installed. It's a matter of energy. So we just need the biggest vibro we can get. And for sure, water jetting. Especially in this case, water jetting would be quite good. In this dense sand, water jetting is the best way to go. Yes, it is. So if we get SPT values, it will always be possible to install sheet piles. That's for sure.
Yeah. So another question is from Mr. Nasir. How are sheet piles coupled when a depth is about 30 meters to be achieved? Coupled, I assume it is the length of the sheet pile that he's mentioning. So maybe you can talk a little bit about that.
Also the sheet
30 meters length.
Yeah. Well, you have to install one sheet pile, and then you have to interlock them above the ground and then drive them down. So later coupling, if you think of installing single pieces with a certain distance or just side by side, You can weld the piles after excavation, but that's not really nice. Also the piles have to be interlocked already above the ground and then driven in the ground, and then there will be no problem. If I understood the question right.
Yeah, coupling it also depends upon the sheet pile that is supplied by the manufacturer. If it is not requiring any on-site coupling, then it would be a single piece that is delivered, or else splice it and weld it or drive it down as a single piece.
Okay, now I think I got it. If you have single piles and you want to install doubles, that's absolutely easy. You just place the singles on the ground. You need some wooden blocks where the piles can slide, and the wheel loader or a forklift to push the piles into each other. That's absolutely no problem. So piles, normally we deliver them in singles or doubles or even triples or quadruples, but it can be threaded on site easily, no problem.
So there's another very small question from Mr. Hemant. How many times can sheet piles be reused if handled properly?
We have customers that have sheet piles on their yard which are 20 years old. They have been used 20 or 30 times. It always depends on how good you treat the piles and how hard the soil is. It's easy to use them 3 to 5 times without any problem. If it's hard driving conditions and the head is a little bit destroyed, you will lose 20-30 centimeters, and then you just use the rest. So we always say 5 to 10 times is not a problem at all. And if the piles are treated well, you can use them for years over and over again. We have quite long references on that.
Yeah. So the next question, I think, is from Mr. Balkumar from Simplex Infra. So is there any separate drivability analysis that has to be checked to check the installation stresses?
Yes, there are different methods that exist. It's always a matter of how good the input data is, and surely the execution on site is a very big topic. We have some little self-made programs that we use in-house. There are programs on the market, so everybody has a bit of its own philosophy. There are recommendations in piling handbooks with formulas where you can calculate. So there are quite a lot of possibilities to evaluate the drivability of a pile. That would go quite far to check now all the different points. Maybe that would be an idea for another seminar.
Okay. There is another question from L&T Infra. Mr. Deepak is asking a question. He understands that the design thickness will be the actual thickness minus the corrosion allowance. So do we have, okay, maybe I'll split the question. It's when we do a drivability analysis, how do you do that? Do you do it with the actual thickness, or do we do it with minus the corrosion allowance? I don't think the corrosion allowance is taken.
It's for sure the actual thickness. It's the piece that you have to drive, not what the piece looks like in 10 years. No, it's the actual thickness that you have to take into account. If there should be a reduction in thickness, that would be important in case the piles should be pulled out in, let's say, 5 or 10 years. Then you can surely think of making a safety evaluation on how much force you can put into to take the piles out again. But for the actual installation, you always use the pile you have. No reduction, no nothing, because that would give the wrong results, because the weight is one of the major factors in sheet pile installation. So it would not be good to reduce there something theoretical, because that would lead to wrong results and wrong dimensioning of installation equipment.
Yeah, and also Deepak, regarding the second part of the question, you can probably get in touch with us directly through DFI regarding the calculation on how it is done. We'll be happy to assist you. There is a question on, again from L&T. You had shown a picture of hydraulic presses, which are like the crush mode ones. When it is on the sheet piles to progressively install the further sheet piles. So how was the first set of sheet piles installed when it is a press?
I guess that will be presented in detail in 2 webinars by Giken, but there are 2 possibilities. Basically, number one is the press is coming on a frame, a starter frame. So you put the frame with the press on the ground, and then you start from there the piling and move away from the frame to the driven wall. The other option is you drive 4 piles conventionally and you put the press on these driven piles. But normally you have a starter frame that's delivered with the machine. It's also the transport delivery device. So that's how the whole process with a self-walking press starts, from a starting frame.
Yeah, thank you. So there is another question from Mr. Bhavin Kotari. What he asks is, the interlocks or the seams, how do we ensure that it remains waterproof? Is it inherently waterproof, or is there some material that we add to make the wall waterproof?
Well, there is a certain natural water tightness in what we call Larsen interlock. When you have it in the ground and there is a water flow, let's say, for example, in a construction pit, then over time, 2, 3, 4 weeks, the interlock will be sealed off naturally. And if that's not enough, we can surely apply different water tightness products. It can be something like a bituminous sealing product. We have a lip sealing product which is applied in the factory for very high waterproofing applications. So it depends on the water pressure that you have and on how much water you have to retain. We can figure out the perfect waterproofing method, which always has to be seen also economically. It should be in line with the budget of the job site. So there we can offer quite a lot of interesting solutions, definitely.
Yeah. So next question I'll take from Mr. Sidhu Ramlu. His how in water bodies, how feasible is the stability of the sheet pile, or the installation of sheet piles to be stable in water bodies? So in what way the sheet piles are supported to stand in the required place?
Sorry, I did not get that one. If we install only in water?
Yeah, there should be a required embedment. So is there any additional precautions or measures that we have to take so that the marine installation of sheet piles are stable?
It has, well, we have the static calculation that gives you the embedment depth, and the installer has to reach that depth. If one pile does not reach it, but all the others have, then it's to be seen with the geotechnical engineer what we can do. But normally the sheet pile has to reach the design depth. And that's what we have to figure out in the beginning, to be sure we have the right equipment to reach the level that we need to reach. Sticking 2 meters out or not reaching the last 2 meters in depth, well, that's not an option.
Right, Ernst, I probably something else that the person wants to ask is, if the installation is happening through a barge, where the crane is positioned on the barge and the crane itself is, or the barge is unstable. So also, how do you
here we are again at the safety precautions. If we work on barges, I did not put in the pictures that I have, and they are not jack-up barges, but just loose floating barges. And we apply forces through the crane into the barge, and the barge is tilting or getting out of balance. That's quite dangerous. So when we work in water, we definitely recommend the use of a jack-up barge, which can, or at least a barge with spuds that can be fixed in the ground, and then the result will be okay and safe. But just a floating barge without any spud, without any pile that holds the barge, that can lead to quite dangerous situations, which we don't like to see. Also, you surely need a good pile guiding system when you work from a barge, because it's quite difficult to get the piles on the right spot in the water. So that needs some engineering up front. But we have quite nice project examples where installation underwater has been done very successful. So if a barge is used, try to get a jack-up barge, or at least a barge that is big enough that the crane loads can be safely introduced and there is no danger of tilting.
Yes, so I'll go to the next question from Mr. Satish from L&T. So what are the disadvantages or precautions that needs to be taken while driving the sheet piles by holding vibro hammers on the side of the sheet pile? Maybe the side grip, that's what he's talking about.
Yep.
So what are the precautions that needs to be taken while driving the sheet piles by holding vibro hammer on the side of the sheet piles? Yeah, side grip.
Safety precautions in lifting always depend a bit on the local rules. If a side grip machine is used, there are some safety equipment or safety, how to say that, safety tools involved. With the side grip, you normally grip the pile, you turn it, you drive it in. There is no additional crane necessary normally, but we are looking only at short sheet piles, let's say 6-8 meters. That's a different thing. When we work with 45-meter sheet piles, then for sure it must be secured at all time that the pile is never unattended. So either we need a second crane or we need a frame that holds the pile. It always depends on the pile size and the situation on the job site. But with the small side grip machines, they normally, once they grip the pile and the machine is okay, there is no defect on it, it will never let the pile loose. So it depends on the type of piling we are working with. Another question?
Yeah, I have, we can take one last question I would want to take. Yeah, I will take the question from Akhila. She's, I think, from Kenya. What is the suggested range of rate of penetration of sheet piles driven using vibrohammer and soft clay to dense sand so that it doesn't damage the sheet pile? Rate of penetration.
That's a bit tricky. Or let's say I don't really get the point. You have to install the sheet piles to a depth that they are stable. So if we have a 10-meter sheet pile, we should install it at least 4 to 5 meters in the ground that it cannot flip over. So let's say 50%. If that is the question, I'm not sure if I got that right.
No, I think the rate of penetration. So probably it is.
The rate of The rate of penetration. Okay. Well, I was talking about the refusal criteria. If we have 5 minutes of continuous vibration without movement, we should stop. So everything below, so if we have, let's say, a minute a meter or even 2 minutes per meter, 3 minutes, as long as the pile is still moving, everything is okay. But at a certain point, you have to consider or reconsider if the installation method is the right one, or if maybe a stronger vibro has to be used, or even an impact hammer should be used. It's very hard to generalize these things. You always have to see it in the field. It always depends on, yeah, as I said in the beginning, on soil, pile, and installation equipment. It's always the combination of those three, and if there is a specific problem, there is always a specific solution for it. So I'm a bit hesitating on the general recommendations on driving speed. As long as the pile is moving, everything's good. If it's moving slow, it's moving slow. But if it's not moving at all, then we have a problem.
Okay, so we don't have time for any more questions, but we will certainly have the questions that received from DFI. We'll answer all the questions and we'll circulate it through DFI, and we will try to be as elaborate as possible in all the answers that we give. Try to include examples also, so that it is more clear to all the people who have attended it and reading the question and answers. Thank you very much, Ernst, and thank you, DFI, for this time allotted to us. Thank you very much.
Thanks a lot.
Thank you, Ernst, and thank you, Amrita. This is wonderful talk, and I think very pertinent questions. An interesting way of answering. Very careful, Ernst. I think, but it was wonderful. I'm glad that everybody's questions will be answered in time to come, and I think we all had something to learn, and we'll have many more things to learn in future as well. So, can we go to the next slide, please? Yeah. So next webinar will be on 23rd September. That is on deep cofferdam quay walls, breakwaters built with circular cells by Joe Martins, Head of Technical and Marketing Department, ArcelorMittal Commercial RPS Sheet Piling. I think I mentioned in the beginning, and I don't think you want to miss it either. So that will be something we'll look forward to at 4 o'clock on that day. And we have a wonderful conference in November coming up, 19th, 20th November. That is DFI India 2020. And as I mentioned, it's a new way, that is virtual conference this year. Before the conference, we had 3 webinars planned. One is gone, and 2 more are coming up, which are basically available to registered conferences, registered persons. So you are welcome to register for the conference, and also sponsor the event. And you can contact people as mentioned at I think in the beginning and at the end also. I think we'll mention again. You can also drop your name if you are interested to discuss sponsorship or otherwise in the chat box as well. So the webinars, as I mentioned, they will be delivered on 17th, the next one, that is EFCC DFI guides to Tremi concrete and support fluids for deep foundations. I would like to talk about this briefly, that if you face recurring problems in Tremi concreting of piles and other deep foundations, or do they impact quality, cost, timeline of the project, that these are the concerns, have been there for a long time. So there was some research and development that was done mainly at Technical University of Munich and Missouri University in Science and Technology, and 3 years of effort by the task force and with multiple inputs from multiple stakeholders, it resulted into a guide to Tremi Concrete for deep foundations. That will be on Thursday, 17, 4:30 p.m. And our third webinar, that is pre-conference webinar, will be on 22nd October, which is on deep mixing equipment and field of applications of the deep mixing methods. So I'm sure you don't want to miss them. Please go ahead and register for the conference. I would like to see all of you to join us there. For that, I think there is a limited time individual registrations for the conference at only 1,500 rupees, which is not much, I guess. You can contact Mahindran or Atif. Their email IDs are given there. You can take a snap if you want. And their phone numbers are also given. Please feel free. They are very nice people. I think whenever I talk to them, I feel good about that day itself. So I think you would like to give them a call as such. And the information is below at the bottom. There is a website. You can find all information about the conference there. And there is a brochure, as I mentioned, on the handout on the right side that you can download for further information. Next slide, please. There are many sponsors that are already on the board, and we look forward to other supporters coming forward as well. So we thank all the sponsors who are making this possible, and please contact Mahindran and Atif if you would like to discuss further opportunities for your company as well. So as I summarize, 17 September, next webinar, which will be pre-conference webinar 2, that is 4:30 p.m. And following that, this webinar series will continue with webinar 5 on 23rd September at 4 p.m. So we would like to see you in both the webinars, and thank for your attention. And a short video is going to be played about the DFI Global Presence. So I am Prashant from IIT Gandhinagar signing off. Thank you all for joining. It was my pleasure attending this webinar along with you. Thank you.
DFI continues to expand globally as regional chapters grow and reach more practitioners with content that meets local needs and goals. Regional chapter leadership is steady, and local staff are dedicated and enthusiastic, liaising productively with DFI headquarters. We are communicating effectively by assembling more frequently through in-person meetings and conference calls to maintain momentum on more than 100 ongoing projects and programs. Stay tuned for what the future brings for DFI. Get involved. Join the DFI community. Become an active member of a DFI committee and join us in making a difference.